Okay, good. So yeah, before go to this, I think to this lesson, uh, I'm going to ask you to again read this chapter 3, about the artificial intelligence modern approach, for the search agent, so and then we'll little bit review about the uninformed search, the previous lecture, and after that we continue with heuristic, so uninformed and heuristic, the informed search actually. Right. So I'm going to show you again to read chapter about the textbook. Do you have this textbook, right, about the artificial intelligence, modern approach? Yeah, I hope you downloaded this textbooks already from library. Problem solving, okay. To show you this book. Can you see the book?
Yes, sir.
Okay, but maybe too small. We'll change. Okay. Zoom on. All right. So again, you read this part, solving problems by searching. Chapter 3, solving problems by searching, and then previously we have learned about uninformed search strategies, right? And then today we are going to study about informed or heuristic search strategies. So then you read this textbook first, then I will come back for explaining this. Okay, so please open the textbook and read this part first, and about after some time, then I will come back. Okay, please inform this one from this part, because so I taken from the previous lecture, a slide from Dr. Asim, and also actually combined from the materials taken from this book as well. All right. Did you read this chapter, this part, about the informed or heuristic search strategies? Here, can you hear my voice? Can you hear my voice?
Yes, sir.
Yes, sir.
Okay. So, did you read this kind of this lesson about the inform or heuristic search strategies? Some part, because of some contents of this lesson also taken from this section, this part. A star, and then the other one is greedy. All right. So the learning objectives, yeah, of this lesson. So at the end of this lesson, yeah, students should be able to describe heuristic, in this case, inform such strategies, and then apply greedy search algorithm, and also identify its properties, and then apply a star search algorithm and identify its properties as well, and identify the properties of heuristic function. So the content, yeah, of these lessons are taken from this one actually, and chapter 3, yeah, in artificial intelligence modern approach. And this slide also taken from the previous lecturer, yeah, Dr. Hashem. All right, with a little bit additional, yeah, in especially in greedy search algorithm. All right. So this is a uninformed search. Yeah, we learned before this one. Yeah. So do you remember about this? Yeah, from our previous lecture. Yeah. So there is a initial state. Yeah, the left side of tiles here. Puzzle 8 puzzle problems. Yeah, the common problems. So we have an initial state. Yeah, the left side here, and we have a goal state. Yeah. So it can be solved by only one move. Yeah. However, if a depth first, using a DFS is unlucky, it could be left or up to try next, right? So that is a depth first. If we use depth first, we just go to the deepest branch, yeah, the deepest child, and if lucky, then we will get solution. That is the thing from uninformed search, yeah, from, for example, from depth first. Because of depth first, we just go from the left line, yeah, the left branch, and after that, if we find the solution, then finish. Right? So then we got the solution and solve the problems. But if not, then again we have to go to the other branch. That is the depth first search. Yeah, if you remember from the previous lecture, yeah, about the depth first search. Right. So here, yeah, the first one, we use depth first. For uninformed search. Yeah, so this is an initial state. Sorry. Problem with the pen. Sorry, I will take another one. Okay, so it works. This one, oh, problem with maybe with the battery. All right. So this is a initial. The left side is initial state, yeah, and the right side is goal state. So we are going to solve these 8 puzzle problems, yeah, from the initial state to reach the goal, yeah, to this position, yeah, with the sequence, right? Okay, so from this one, yeah, we use the depth first, and yeah, we can find the solution directly. Yeah, if it is unlucky, then we could pick the left or up, yeah, to try the next. Right, so then the first one, for example, here, yeah, so we move, yeah, the blank tile, yeah, to left, right, yeah, to left, and then we got this position, right, yeah, this one from initial state, okay, yeah, and then if we use another one, yeah, here, so the next one, yeah, so tap to try next, yeah, from this one, yeah, we move this one, we move to up, yeah, the blank tile, and we got this one, right, up, so this one, yeah, up, so then now the position of the tree is actually below, yeah, so then the blank tile will be on the top corner, the left, oh, sorry, the right corner here, yeah, yeah, so this is the next one, yeah, so it can be here, yeah, the one, and the other one is here, right? So this would result in worse position than the starting point position, yes, and there is the search might never try down, yeah, so then if we try down, then we got actually the, you know, the result, right? So but then we, because of we start with the left and up, so we do not find the result, right? So and find the right move, so because it is not informed about the concept of better or worse states. So in this case, we try the first one here and the second one, and the third one is actually the solution, right? If we see here, yeah, so move blank tile to down, right? So then 6 will be up here, right? So then this position will be the other one. If we move down, 1, 2, 3, 4, 5, 6, and 7, 8. This is the location or the position if we move down tile, this one, the original or the initial stand, right? So that is the thing. So but then if because of we, you know, the concept, yeah, because of it is not informed, yeah, about the concept, so then we cannot get one move, yeah, or immediately, yeah, so then we try this one, another one, and finally this one, yeah, with the down move, then we got the goal state here, yeah. So that is the actually why heuristic search for found here or developed, so actually to, yeah, to optimize or to minimize, yeah, the moves, yeah, from the previous method, so then we can get fast or quick solution, yeah, to solve the problem, right? So heuristic search here to efficiently solve a problem, so we can force the search and try the best or the most promising move first. Yeah, that is the thing here, the heuristic search. So in the case of the last 8 puzzle, so we want this one, the point, yeah, to force down to be the first move. Yeah, that is the thing. Yeah, so then, yeah, we want to force down this one. Yeah, put down. Yeah, and then 6 will be up to do it to be the first move. All right, so then we can get the solution immediately. Yeah, because actually with this initial state, we can solve this problem only with one move, right? Yeah, but with by using uninformed, maybe we put the wrong direction. I mean, at the first stage, we move. It moves to the different direction or wrong direction. So after some moves, then can find or can get the solution. So in heuristic, we try to solve this problem, then search the best moves, yeah, or the most promising move first. That is the point for heuristic search. So we can use some problem or domain specific knowledge, or we say heuristic information, yeah, to guide the search. Yeah, that is the key point of heuristic. And then this kind of search strategies is called informed search, yeah, or heuristic search. And then heuristic search actually applies a heuristic function. Yeah, HN is a heuristic function to state node N. Yeah, this is node N, and which measures how promising the node is or the desirable of the node. Yeah, that is the heuristic. And usually it describes how far we expect the goal state to be from the current state. Yeah, current state of N. Yeah, and the lower of the heuristic value, the more promising or more desirable the node. That is the point. So if the heuristic value lower, yeah, then the more promising way or moves actually or desirable the node. Yeah, the node. That is the thing. Right. So for 8 puzzles here, a useful heuristic function could be, yeah, we can we say the here the tiles, the first one, yeah, tiles out of place, yeah, or H1, we say, yeah, number of tiles which are misplaced, yeah, or H1, so H1, not HI. Yeah, H1, yeah, H1. And then the second one is Manhattan distance, yeah, or total horizontal and vertical distances of tiles, yeah, to the target, and it called as H2 here. Manhattan distance is also known as a city blocks distance. So, for example, by heuristic function, we have this one, yeah. Yeah, this is the goal state, all right. And then what are the heuristic values of the above function on the following state? Right. This is the following state, yeah, for the condition, yeah, for after this is the goal state. This is the following state. Yeah, so the goal state, yeah, supposed to be 8 here, right? So because of the goal is actually to make it sequence, or in order like this 1, 2, 3, 4, 5, 6, 7, 8, right? But in this location, in this position, 8 is not in the right place. So from this, yeah, we say that H1, yeah, for S1, this one, the condition, yeah, H1, yeah, number of tiles which are misplaced. How many tiles misplaced in this condition, in this states? How many tile misplaced? You refer to this one. This is the goal. So from the goal, yeah, this state, yeah, S1, how many tile misplaced here? 1, 2, 3, right. the right location, right? 1, 2, 3, 4, 5, 6. Same location or not with the goal? 4, 5, 6.
Same location.
All right.
Same. Yeah.
And 7. You refer this
7 also same.
same,
8.
all right. Only 8 misplaced, right?
Yes.
Okay. So then from here, yeah, we see, yeah, H1, only 1 tile misplaced, right? So this is, what is the number? Number 8, right? Which is misplaced in this state. And then H2 is actually Manhattan distance, total horizontal and vertical distance, yeah, from the goal. So how many moves that we reached the goal, yeah, for the misplaced tile here. So this is 8 is misplaced, only 1, right? So how many moves to reach the goal? The 8 from that location to the goal. From this is the goal, this is the state, yeah. So how many move 8 to be reached? I mean to reach the goal here, to be the same as the goal. How many?
1 move.
1, yes, only 1 move needs, right? So 1 move needs here, 1 move here from 8, yeah, this one 8, yeah, to left, right? To left move, yeah, here horizontal move, yeah, because there is a horizontal and vertical moves, yeah. So here, yeah, from right to left, yeah, only 1 move. So the H2, yeah, for step 1 is 1 also. So that is the heuristic, yeah, for example in the step 1, right? So the number of the tiles out of place is only 1 for step 1, and the number of moves, yeah, in order to be the same as the goal, yeah, the location or the state, yeah, we need to move 8, yeah, to the left, yeah, from the right corner to the left in the middle here, bottom middle, yeah. And yeah, so only 1 also. Then in this condition, yeah, H1, yeah, in this state, H1 step 1 is 1, yeah, and then for the Manhattan distance, H2, yeah, H1 equal to 1 as well. So what happened with this one, the second condition, yeah, H2, yeah, 1, 3, 6, 4, 2, 8, yeah, 7, blank, and 5. So this is the state 2, right? So we check, this is the tile, yeah, on the state 2. Yeah, this is the goal. The goal is the same. So this is step 2. So we check first, yeah, how many tiles out of place, yeah, or misplaced in this S2, yeah, or step 2. How many tiles?
Misplaced 5.
Yes, misplaced. How many tiles? So this in S2 here.
3.
7.
No. Yeah. I
Seven.
mean, you mean tile number 3? Yes. Tile number 3, yes. Misplaced. And tile number what? What number again? Misplaced.
147.
7. As you see the goal is here. Here the goal.
It got, yeah.
Yeah, the goal. So then you can see you always refer to the goal, right? Because this is the state, the current state. This is the goal. So we are going to reach the goal actually. So in this case, we should maintain the right tiles, right? The right place. Because we will move only the wrong place in this case, yeah, in the heuristic function. So in this case, tile number 1 is the right place or not? If we refer to the goal, is the right tile number 1. The goal is here. Wrong or misplaced? Number 1. The tile number 1 here, yeah, is in the wrong location or the right location?
Right location.
Right location, yes, because of the location in the goal is here, just the corner up, yeah, left side, yeah, left side here, and then exactly on the corner here, the top, yeah, top corner here. So then it is the same with the goal. So means that this is the right place. So this is not the misplaced, right? And then number 4. So we identify the right place first, then we can easily calculate or count the misplaced. Yeah, number 4, is it the right place or wrong place?
Right location.
Also right, right? So because also right here.
Yes, sir.
Yeah, right here, number 4 here. This is number 4 here. Right, and then number 7, is it the right place or wrong place?
Right.
Right place as well, yeah. So 1, 4, 7 are the right place according to the goal here. Yeah. So you always refer to the goal, yeah. So because of actually the states, yeah, we measure the states to the goal, yeah, because of we are going to provide or to give the solution, yeah, to reach the goal. So that's why we have to always refer to the goal. Yes, then go to the next one. Yeah, 3 is tiles number 3 here. So is it the right place? Yeah, according to the goal?
No, sir.
No, right, yeah, because of this is the goal is actually on the top corner, right side, right? The right top corner here, number 3. But here in the top, but in the middle, right? So that is, so means that this is wrong. Yeah. And how about the tiles number 2 in the current state in S2? Is it wrong or right according to the goal? Number 2.
Wrong.
Wrong also, right? Yeah, this is wrong place also, right? Out of place. Yeah, because it's supposed to be here in the middle up, yeah. Yeah, the first row, right? So that is a 2. Yeah, 2 tiles misplaced already. And then we find the 6 here on the state 2. 6, is it right or wrong? Number 6 here. If we refer to the goal, is it out of place or the right place? Number 6 on the state here. Also wrong, right? Yes, because supposed to be here. Yeah, the right side, in the middle, yeah, or the third column, yeah, the second row. Yeah, so but here the first column, the third row, yeah, sorry, the first row, the third column, yeah, here 6 supposed to be here. So this is misplaced or out of place. And what happened with 8? Is it wrong or right according to the goal? So you have to understand this process because this is very important. And yeah, however, in the exam you have to count manually like this. So that's why we are not using the for the theory exam, yeah, theory test you have to use manually. But in practical, yes, of course you can use computer because we use the code, yeah, programming. But for theory test, yeah, theoretical, then you perform this calculation, yeah, manually. All right, so 8, yeah, tile number 8 here. Is it the wrong place or out of place or the right place?
Wrong place.
Wrong place also, right? So because we have to know the what's it, how to construct, yeah, or how to provide the solution by using the heuristic. Yeah, this is a bit complicated, yeah, if compared to the previous, yeah, more complex if compared to the previous search algorithm, yeah, or such methods. So we have now 4 tiles out of place. Then the last one, tile number 5. Is it misplaced or out of place or the right place? Misplaced or the right place? Number 5 here.
This place.
Misplaced also, right? So this one, out of place also, right? Number 5. So how many out of place? How many tiles are out of place in this
5.
5? Yes, in S2, yeah, this step 2, yeah, according to the goal. So then we have H1, yeah, 5 tiles, yeah, out of place. So you get the point? Understand? Until this, because of this, very important to understand H1, H2, yeah, in heuristic function before we proceed to the the greedy and A star. H1. Yeah, this is H1, H1 5. Yeah, so we have a just you can quickly find, yeah, which tiles are the right location. Yeah. So then after that, the remaining will be the misplaced, yeah, or out of the place. So that is how to quickly recognize like this. Yeah. So we have this one, yeah, the goal, and we have this one, the state. So just we find, okay. So number 1, right place. Number 4, right place. Number 7, right place. Number 2 here, yeah, the current state, yeah, S2, yeah, out of place. Number 3, out of place. Number 6, out of place. Yeah, number 5, out of place. So then the remaining 5 are out of place. Yeah. So we just recognize which tiles are the right place, and after that remaining we count to confirm that those are out of place, yeah, for the tiles. All right. And then now how to calculate the Manhattan distance, yeah, or the total horizontal and vertical distances, H2 here. And this is H1. Yeah, tiles out of place, and second one is H2, yeah, or Manhattan distance. So we find, yeah, H2 actually how many moves, yeah, that the misplaced tiles can reach to the goal, yeah, or at least can be the same as the goal here. Yeah, I mean, if we refer to the goal, means that we have to reach this goal, right? So how many moves? This is how to count H2, right? So for H1, we just find how many tiles misplaced, yeah, or out of place, and then H2, we find the total horizontal or vertical distances, we can say, of the tiles to the target. Yeah, vertical or horizontal distances, yeah, to the target, yeah, from the current state to the target. Right. So that is a H2. So how to calculate or how to count here? Yeah. So the first one, yeah, we check number 2 here. Number 2 in the center here, exactly. So number 2, how many moves needs to, yeah, to reach the goal here? Because of the original,
1.
yeah, only 1, right? So we move only to the top,
right? Yeah, to up here, right? So to move to up. Then we got this one only one move. Yeah, so we reach the goal. Yeah, for 2, right? So one move. And what happened with 3? 3, the right position here. The goal is here on the corner, top corner, right? A row, first row, and the third column. So from here, yeah, to the goal, how many move?
This one also one.
Also one, right? So because we need to move from here to here, right? This is number 2. We move to here. One move. Yeah. This one also one move. Yeah. How about the 6? Yeah, 6. Because we move 2. Yeah, already 3 also one move. Yeah, 2 one move, 3 one move. Yeah. Tile number 3, tile number 2, and now tile number 6. Yeah, how many moves? So the goal is exactly the bottom of the original. Yeah, down exactly from the not from the current state. I mean here. So how many move?
One.
Only one move, right? So then reach the goal here. Yeah, one move, and then yeah, what happened with 8? Here, 8 here in S2. 8, the location is in the third column, the second row here, and then the goal, yeah, should be in the third row and the second column here. So how many moves? Yeah, to be here,
2 moves.
2 moves.
moves.
Yeah, so it needs to move here, and after that, sorry, I don't know, always appear. Set a straight line here. Okay, so move to here first. Yeah, the next tile. Yeah, the next and then move to this location. So then this is the right location and the goal. Yeah, so 8 have 8 this one. Yeah, has the 2 moves here. 2. That's why you put 2. And then now the last one, 5. 5, how many moves to reach the goal?
5, 2.
2 also, right? So because of the goal, yeah, the 5 location is exactly in the center here, right? In the center here, the location. So the current state, yeah, tile number 5 is actually on here, the third row and then the third column. Yeah, so then we need 2 moves. Yeah, to this place and to this place, to the center. Yeah, so this is 2 move. Yeah. So from here, yeah, 5 tiles out of place, and we have 1, 1, 1, 2, 2. Yeah, 7 moves. Yeah, yeah, because of tile number 2 needs 1 move. Tile number 3, yeah, here, tile number 2, tile number 3. Yeah, this is tile number 2 actually. Tile number 3, yeah, needs also 1 move, and tile number 6 needs 1 move also, yeah, in order to reach the goal. And then tile number 8 needs 2 moves, yeah, to reach the goal, and tile number 5 needs 2 moves also. So then we got 7, yeah, for Manhattan distance. Yeah. So understand until this step. This is very important, yeah, because of this one, the basic for heuristic function. Then you have to understand, you know, from where we find H1 and also H2. Yeah. Any question or any comment until this part? Clear? so far?
Okay.
So yeah, so this is H2 7. Yeah, 7 from where? 7? 7 actually from 1. Yeah, the moves of the number of moves of the tile 2. Yeah, number 2, and tile number 3. Yeah, needs 1 move. Tile number 6 needs 1 move. Tile number 8 needs 2 move. Tile number 5 needs 2 moves to move in order to reach the goal. Yeah, so we have always refer to the goal, right? Because of the idea, we want to solve these tiles, yeah, or these 8 puzzles problems to finish or to reach the goal. Right, so then H2 7. So a heuristic doesn't have to be perfect. Yeah, for example, exact distance to goal. Right, so this is the thing, and this is just the theoretically a calculation. Yeah, so based on this calculation, yeah, this is informed search. So that's why with this calculation, then maybe we can get the precise or accurate solution. Right. So these are the pseudocode for informed search. Yeah. So we follow best first search, yeah, BFS, but BFS for best first search, yeah, not the breadth, because we have also breadth first search, yeah. BFS and DFS. This is a best first search, yeah, approach. So it is actually similar to uniform cost search, yeah, if you remember from the previous lecture, yeah, lecture 3, yeah. We have UCS, yeah, uniform cost search, yeah, except we use function F, yeah, in this case instead of G, yeah, to order the priority queue. Yeah, so then the best first algorithms include heuristic function HN, yeah, as a component of Fn. Yeah. Yeah, so then with this pseudocode, yeah, open is a priority queue and start node and close, yeah, if empty. And while open is not empty, then do, yeah, the movement, yeah. So remove the first state from open and call it, yeah, and yeah, if X is a goal and return path from the start to X, yeah, and after that put X on the closed, yeah, because already given the moves, yeah, and generate all successors of X. Yeah, and for each successor of X, yeah, do with this current function, yeah, deal with it, yeah, successor, yeah, and then reorder the nodes in open by value of F, yeah, for a priority, yeah. So then later on we can try this code, yeah, by using the Colab. Right, so these are the next pseudocode, yeah, for informed search, yeah. So that is the case, yeah. The state of successor is not in open or closed, so we have to assign, yeah, the successor a value by a function, yeah, F as a successor here, and add the successors to open, yeah, only using open and close method also. And successor is already in open, yeah. If its state was reached by a smaller value, then update the successor value in open, to the smaller value, and update the path to the newer path. Yeah, that is the condition one. And for the case, the next case, the successor is already in close. Yeah, so if its state was reached by a smaller value, then remove the successor from closed and update successor value and new parent state of the successor to open again. All right, so then the evaluation of function here. Yeah, the function Fn, yeah, in pseudocode of informed search is evaluation function actually. Yeah, an evaluation function can be applied to any node. Yeah, and the node with the smallest evaluation value in open is expanded next. Yeah, if it is open, then it can be expanded for the next step. And different choice for Fn, yeah, is for the function, give different kind of search. Yeah, and if Fn equal to Hn, yeah, this is the evaluation function is a heuristic function actually, then it is a greedy search. Yeah, this is the condition. Yeah, so because we have we will cover the technique for the heuristic, yeah, the heuristic search. Yeah. So this is the condition. Yeah, if Fn equal to Hn, then the function is heuristic function, yeah, the evaluation function, then it will be, or it is a greedy search. Yeah. This is the first condition. So if Fn equal to Gn, yeah, what kind of search it is? So this is UCS, yeah, uniform cost search. And then the other one, yeah, if Fn equal to Hn, yeah, equal to greedy search plus Gn, yeah, plus the UCS, this one, yeah. So combine heuristic function and path cost function. Right, so heuristic here, yeah, and then cost function here, yeah, UCS, uniform cost function, yeah, or cost search. Then we got A star search. Yeah, so we have two method, yeah, two techniques in a heuristic. The first one is greedy search, and the second one is A star search. Yeah, yeah, yeah. So this is the condition, yeah, when it is a greedy search, yeah, Fn equal Hn, and the condition for when it is A star search, Fn equal to Hn plus Gn. All right. Can you hear my voice? Do you hear my
Yes, sir.
voice? Okay, good. All right. So we continue this one. Yeah. So based on this, yeah, so we can determine, yeah, the condition, yeah, for greedy search, yeah, and based on the evaluation function, yeah, and A star search. So actually, A star search is the combination of heuristic function and path cost function, yeah, or UCS. Then greedy search, yeah, for the first one. Yeah, so greedy search uses the heuristic function only, yeah, as its evaluation function, yeah, as you can see from the previous slide here. So greedy search is using the heuristic Hn, the function, yeah. Here is a heuristic function only. So that is a greedy search. Yeah, so only using heuristic function, and it's as its evaluation function. So for example, here a puzzle problem, yeah, could use H1, yeah, tiles out of place, or H2, yeah, Manhattan distance. Yeah. So I will check. Where is the slide here? Okay. So can you see the slide?
Yes, sir.
All right. So yeah, H1, yeah, actually tiles out of place, and H2 is Manhattan, yeah, distance. So H1 we can say as the Hamming. So based on the, if I check from, yeah, the reference, yeah, H1, we can say Hamming distance, yeah, and
H2 is Manhattan distance. So this one, H1, right on. Later on, I will add on the slide. Yeah. So this one we can say as Hamming. Yeah, some reference mentioned about Hamming distance. Yeah. So actually the same as tiles out of place. Yeah, and then the second one, yeah, H is H1, and H2 is actually Manhattan distance. Yeah. So the total horizontal and vertical distances. Right. So here, yeah, Hamming distance, yeah, H1, yeah, tiles out of place, or H2 Manhattan distance, yeah, for example of puzzle problems. Yeah. So as mentioned in the previous slide, yeah, we see the goal state. The goal state is like this. Is the goal state. Yeah, goal. We have to always, yeah, refer to the goal. Right. So we have to refer, yeah, always, yeah, the goal. Yeah. So this one is the goal. Yeah, this condition, right? Goal state, and then this one, yeah, the bottom tiles here as the initial state. Yeah, initial state or the current state. Yeah. So this example uses H1 as evaluation function, using the heuristic function. Yeah, only H. So from this condition, initial state, yeah, how many H1? I mean, H1 is, as you know, H1 is tile out of place, right? So based on this initial state, yeah, we say, for example, state 1 here, this is goal. Yeah. So based on the goal, yeah, in initial state, yeah, how many H1, how many the tiles out of place? Yeah, you have to remember. Then you check, yeah, how many tiles on the right position, location, and after that, assume the remaining are misplaced or out of place. Then after that, confirm one by one. So here, yeah, the initial state, yeah, only tiles number 2 and 3 are on the right place, isn't it? Can you see?
Yes, sir.
Yeah. So how many tiles that on the right place on initial state?
2,000 rupees.
Only 2, right? On the right location. I mean the right place. Only 2 and 3 means that only 2 tiles. Yeah. So if as we can see here, so number 2, check. Yeah. Okay. So we find or we look one by one. Right. So number 1, yeah, here in S2 in the state, sorry, in S1 in the state 1 here in the initial state. Yeah, is it in the right on the right place or not? Number 1, tile number 1. Tile number 1 here. Yeah, this is the goal. Is it on the right place or not?
Misplaced.
Misplaced, yes. So number 1 is misplaced, right? Because so number 1 is supposed to be on the top corner here, left side. Yeah, so on the first column and first row, right? So but in the initial state, yeah, the current state, number 1 is on the second row, the first column. Yeah, the column is the same, but the location is on the second row.
Yeah, so it is misplaced, yeah, or out of place. Okay, and number 2, is it the right place based on the goal? Number 1, not the right one. We say cross like this. And number 2, is it the right place if we refer to the goal?
Yes, sir.
Yes.
Yes, okay, right place. And then number 3, is it on the right place based on the goal if we refer to the goal?
Yeah, right place.
Yes.
Right, okay. And how about number 4, tile number 4 on the S1 here? Is it on the right place?
Misplaced.
Misplaced, all right. This is misplaced. And how about the tiles number 5? Is it right or miss?
Yeah, misplaced also.
Misplaced also. Right. And then how about tile number 6 here? Is it misplaced or right place? Number 6 in initial state.
Misplaced also.
Misplaced also. Right. And number 7 here in initial state. So you refer on the goal. Is it misplaced or the same place as the goal? The right place?
Misplaced.
Misplaced, yes. And how about tiles number 8? Misplaced or right place based on the goal state?
Misplaced also.
Misplaced also. So based on the goal, we have 2 right place and 6 misplaced, out of place, right? So then for the heuristic, so function here, yeah, for the greedy search, function is equal to heuristic. Yeah. So for H1 here, yeah, F equal to H1. So how many tiles out of place? So since we have counted here, we have a 6, right? So the function here, heuristic, yeah, we have a 6 out of place, isn't it? Yeah, please follow this explanation, because of this one is very important. Yeah, otherwise then maybe you cannot solve, or you cannot find, I mean, for example, h equal to 4, from where h equal to 4, or h equal to 5, yeah, from where we get h equal to 5. Because this one very important when we change, yeah, for example, in test or in exam, yeah, we change the location of initial state, then we can create the new problem. Yeah, then you have to solve according to this. For example, greedy search, yeah, or heuristic search, yeah, by using the greedy search method. And because of to construct the the question, yeah, from this is very easy. Yeah, you just change 1 tile or 2 tiles here, yeah, and then we'll create the new problem. Yeah, we'll give the different solution. Yeah, for example, here 1, 4, 5. Then I move 1, 7, 8 here and put 4 and 5 here. So we will create a different step. Yeah, different solution. So that's why please follow this explanation. Yeah, at least you can think also. And if you have any doubt, yeah, or any questions, so just we discuss together in this lecture, right? So then we can find the solution. That's otherwise then you will miss this kind of knowledge, yeah, how to find the heuristic here. All right, so the first from the initial state, so we got this one, yeah, h1 equal to 6. Yeah, so from this, yeah, we divide, yeah, into the branch. Yeah, so as we mentioned, as mentioned in the previous lecture, yeah, in the previous class, yeah, actually, if I'm not mistaken, in lecture 3, lecture 3 about the deep force search, yeah, or even BFS also still the same, yeah, using this, but this one, yeah. So we have how many possibilities here from S1, yeah, from initial step, yeah, to create the branch here. So the possibilities of the tile, the empty tiles or the blank tiles to move is to down, right, and to the left, isn't it? This one, these are the blank tile, yeah. We can move, yeah, only to left, sorry, to right, yeah, to right, yeah, not left, sorry, to the right step and to down, isn't it? For this one, so I will
Yes, sir.
Yes, sir.
yeah. So we have a possibility. I will delete this one verse, not to be confused with how to count a heuristic, yeah, for the first step. Right. So yeah, we focus on the blank or the empty tiles here. Yeah, we have one empty tiles, yeah, on the top corner, right, the left side, top corner left side. Yeah, so from this location, yeah, from this position, there is a two possible moves, right? To down, yeah, the blank tiles, or to the right, right? So because of it cannot move to the diagonal on the diagonal step, so it only moves to the vertical or horizontal. So then we have two possible branches here, right? So if move to down, the empty tiles don't become like this, isn't it? And this is move to down, we say. So I will make it more here. Yeah. So if we move to down, then we'll become like this, right? So if empty tiles moves to down, then will become like this. Yeah. Then the empty tiles will be in this position, right? And then if empty tiles move to the right, yeah, to the right side here, then will become like this, isn't it? Then do you understand for until this step? We have two possible moves,
Yes, sir.
from initial step for the blank or the empty tiles. Yeah, only two possible moves. Yeah, since the location or the position of the tiles exactly on the top left corner. Yeah, so then we have only two possible moves. Yeah, the first one is actually moving to down. Yeah, so will become this step. Yeah, move to down, and the second one move to right. Yeah, and will become this location position. All right. So then now we find how many tiles out of place. Yeah, the next step. Yeah, after we divide it into two branches. Yeah, and we construct two branches here. Yeah, the first one down and the second one right. Then we find again, we calculate, yeah, heuristic of this new state, yeah, of this new condition. Right. So we say okay, let's say this one S2. Yeah, S2 down and S2 right here. Yeah. Yeah. Then for down, yeah, we can see how many tiles are misplaced here or out of place in this one, in this condition. In this condition, how many tiles? So we check one by one. Yeah, but if you are familiar with this method, actually you just find which are, I mean, the right location. Yeah, and then the remaining will be the misplaced or out of place. Yeah, which tiles are on the right location or on the right position. Yeah, and the remaining tiles will become out of places. All right, so if you want, you can, I want to show you, yeah, this step by step, yeah, to solve this one. So again, check number one here. Number one, is it misplaced according to goal? Yeah, according to the goal, you should refer to the goal here. Yeah, the goal is very important. Yeah. You do not refer to the S1. That is, you have to remember. Yeah, even though this is S2, yeah, the step 2, but then you have to refer to the goal. Yeah, because we are going to reach the goal. Yeah, not S1, not the initial state. This is just initial state, the first state. Right. So then, in this case, we find we confirm first. Okay, one, tile number one, is it the right place or not according to the goal? Tile
Yes,
number
right
one,
place.
right place, right? Isn't it?
Yes.
Okay, so this is right. Yeah, tile number one. How about tile number two? Is it the right place according to the goal?
Yes.
Yeah. Yes, okay. So please follow, yeah, please follow. The other student, please follow, because of these are very important, yeah, to know, to understand step by step, yeah. At the end, you have to solve the problem during the theory exam, yeah, or in the test, yeah, theory test. Use a manual calculation like this, yeah. So because you do not use the algorithm, yeah, unless for practical test, yeah, when you construct the code, yeah, and after that you can solve very fast, yeah. But you have to think the code, how to construct the code. All right. So then now number three, tiles number three. Tiles number three here, is it the right place according to the goal or not?
Yes.
Yeah. Okay. So tile number three is the right location, the right position according to the goal. And how about tile number four? Tile number four here on the state two, yeah, is on exactly on the center here, center of the tiles, yeah, the 8 puzzle, yeah, or this is nine tiles actually, but we say 8 puzzle, yeah, because only 8 that we have to solve. Yeah, one tile is empty. So number four, according to the goal here, is it the right one or misplaced? Number four here exactly on the center, but on the goal is not on the center. So means that this one is misplaced, right? Out of place. And how about number five? Number five refer to the goal. The location is on the third row and the third column, right? But here on the second row and the third column. So it is misplaced again. Right? And how about the number six? Yeah, refer to the goal here. Number six, is it the right location, the right position, or misplaced?
Misplaced.
Misplaced again. And number seven, again misplaced. Yes. And number eight,
Misplaced also.
Misplaced
Misplaced also.
again, yes. So then how many misplaced that we have here in state 2? Yeah, second state here. 5, yeah, here. So then we got H1, yeah, heuristic, yeah, 1, or tiles out of place, 5, yeah. Number 4, number 5, number 6, number 7, and number 8. Number 8. Number 1, 2, 3 are the right place, on the right place. So I actually based on the goal here, according to the goal, are the same place, right? So we have 5 for heuristic, yeah, for the second state, yeah, here for the S2 here, right? So then we go to the other branch here from the right moves, yeah. You remember here. So S2 but right moves, yeah, yeah. And we say, yeah, for example, we say S2A. And this one S2B. Yeah. So in S2B, yeah, here the second step with the B, yeah, another branch. Yeah. So we find how many tiles out of place. Yeah, using the same method as we have done. Yeah, in the previous tiles here, in the previous state, yeah, S2A. All right. So then since we recognize here, yeah, 1 is out of place and 2 also out of place according to the goal here. Yeah, 1 supposed to be on the top left corner here, but on the step S2B, yeah, is on the first column, yeah, the same first column, but the second row, not the first row. So then it is misplaced, out of place. And number 2 also out of place, yeah, because of here on the first row, the second column, but in this S2B, the second step B, yeah, the first row and the second column. So the different column here, so misplaced. And then number 3, how about number 3? Is it the right place? Yeah, according to the goal. Yeah, in S2B. This one.
Yes.
Yes. Yeah. So the right position according to the goal. And how about number 4? Misplaced, right?
Misplaced.
Yes. Number 5 again misplaced because of here. Yeah, the third column, the second row, yeah, in S2B. But in the goal, yeah, we see that number 5 actually on the third row and the third column. So it is misplaced, yeah, out of place. And how about number 6? Here in S2B, also out of place.
Misplaced.
Yes, misplaced. And how about number 7? Misplaced again. And number 8, misplaced again, right? So how many misplaced in this state? Yeah, S2B?
7.
7, yes, exactly. So we have 7, yeah, misplaced. Right. So then from this, so we decide, yeah, we can decide that, yeah, of course, this one, you know, even from the initial state, yeah, the misplaced tiles becoming more, right? The previous one, 6. Yeah. So based on this, we find this is even more than. Yeah. So H1, yeah, F in S2B, yeah, actually, sorry, the more than, yeah, more than. And this one, yeah, less than. So we find the less, yeah, the less heuristic, yeah, for the next. Yeah, then we stop this one, yeah, and we continue the branch, yeah, with this one, with the less heuristic, yeah. So with this branch, right here, with H5, because of it becomes less misplaced than the initial state, right, from this one, because we find the zero, yeah, the zero for this one, the function, yeah. I mean, in terms of tiles out of place, of course, the target, yeah, the goal is 0, yeah, the H is 0, yeah. 0 means there is no tile of out place, yeah, or no misplaced tiles, yeah. All right, so any question until this part? So we select this one, yeah, we select this one, yeah, because of this one, the heuristic, yeah, the tile out of place less than, yeah, the what's it, sorry, I put the wrong symbol here, less than the initial state, yeah, heuristic of initial state.